Investigating the centroid, you're going to need a straight edge. I recommend some patty paper instead of the traditional compass this time, and have a highlighter and a pencil. And of course, other color pencils if you want. Let's go ahead and acknowledge that as mathematicians in this activity, we are going to look for and make use of structure, and we're going to look for and express regularity in repeated reasoning. Like what we do for one example, we're going to do for another. We're going to learn about a new vocab word, but it's also a vocab word where you're like, haven't we been doing this already? You have. A median of a triangle is a line segment that connects a vertex to the midpoint of the opposite side. So I'm going to highlight all of that right there. You're going to construct 3 medians for each triangle. So we'll need the tracing paper in order to begin the construction, and you'll need the straight edge to complete the construction. Let's do the acute triangle. Now it says acute triangle, not equilateral, right? So there are the 4, and these are the same 4 triangles from all of our previous shapes. Take the tracing paper and trace a side of the triangle. Well, I'm going to trace the whole triangle, actually. All right. Try to be precise. Maybe put dots on the vertices. Right, the word that we're going to be learning about in investigating the centroid. Centroids are made with medians. So in order to create a median, we're going to take this point of that vertex of the triangle and move it onto the other one. Now I'm going to go this way. You could go around to a different point, but the point is that you're going to fold that line in half so that you kind of see it on the screen there. I'm going to bring this point on top of that one. So a little adjustment. Once it's there, crease the line, but you don't need to crease a lot of it. You just need to crease right there where the lines meet. And then open it back up, put a pencil on the crease. That's the center of that line segment. That's the midpoint is the better vocab word. And then let's push it into the picture right there. That's the midpoint. By the way, I also created the perpendicular bisector. So this is the same construction as a perpendicular bisector, but I don't need the whole line. I just need the place where the perpendicular bisector crosses our side. There are 3 sides of the triangle, so do this again for the other 2. Get a crease. And get a crease. And then I'm going to go back to the triangle. I'm going to push. I guess I could do the trick. I'm going to do the trick where you put graphite on the other side of the tracing paper and then trace the trace. Oh, that's really cool too. You can kind of see where the perpendicular bisectors are meeting. We're not making perpendicular bisectors. We're only making the midpoints. But it is kind of nice to see that on the tracing paper, the creases are making this lovely little pattern in the middle of the triangle because they're making circumcenters. Now, a median, you're going to connect this angle to the opposite side at that side's midpoint. So connect this angle to the opposite midpoint. And then do that for all 3 sides. This angle to the opposite midpoint. And this angle to the opposite midpoint. They're concurrent, which means they all meet at the middle. This is the centroid. Boom. That's the centroid. I love this one because there's 2 reasons why centroids are useful. 1, it's an easy construction to do. And secondly, this is also known as the center of balance. If you have to create a triangular shaped object and that it needs to be able to balance, you use centroids. Centroid. Okay, so repeat. I'm going to kind of go on silent as I just make it and just make all 4 of them. So there's 1, here's 2, the obtuse triangle. You can go ahead and skip forward in the video or pause it, do them yourself, and then compare if we did the answers right, or just see step by step what I'm doing in order to create them, but it's kind of straightforward and easy. Here we go. Once again, I've created a circumcenter because perpendicular bisectors cross, and where the perpendicular bisectors meet is the circumcenter of the triangle. It's the place where you can draw a circle that touches all the corners. But I don't need the perpendicular bisector lines. I just need where they cross the middles of the triangle. And then, remember the trick, flip the tracing paper over to trace on the back of it, so that when you flip it in returning it, tracing the trace will leave a graphite mark on the paper. There they are. Make them be a little more visible. And now, connect an angle to its opposite midpoint. Connect an angle to its opposite midpoint. How easy is that? Like, I feel like this is just one of those real simple, like, duh, it's just right there, you just do it type of constructions. Concurrent in the middle at the center of balance. Okay, right triangle. If you're not already doing the trick with YouTube where you're using the playback speed to accelerate this section, you should, right? You should really think about using that feature. Or certainly you're skipping forward and seeing what I'm doing and then coming back to it. Okay, I've traced the triangle. Now I'm going to work the paper to fold each side of the triangle in half. And it's got to be in half, which means you've got to be precise, which means don't mess up. And then mark the crease by marking the midpoint. Excuse me. All right. The three medians of any triangle will intersect at the centroid, which is also known as the center of balance. I did leave you with equilateral triangle to do. Figure you can do that one without too much prompting from me if you follow the steps that I did in the previous three triangles. Thanks for watching this video on page 270. Activity 3 on investigating the centroid will continue on the next page, page 271. We want to talk about what it means to have a centroid. Thanks for watching this video. See you in the next one.